So dear students, in this video we will again be discussing a very important topic, and that is what is known as relative motion. So this is a topic which many people are confused about, and people think like how to solve the questions related to relative motion. Now when we say relative motion, it means simply motion of one object with respect to another. You can say motion of one object with respect to another object. Now in very simple words, if two objects are moving, let us say two moving cars, दो कार जा रही हैं same direction में, let us say. So if those two cars are moving, then how does one find the motion of the other? Now very simply speaking, if two cars are moving with the same speed, of course we say that they are at rest with respect to each other. I am repeating what I said. If two cars are moving with same speed, suppose it's moving with 60 kilometers per hour and this is also moving with 60 kilometers per hour, then we say that the speed of one with respect to other is zero. So relative motion is essentially motion of one object with respect to another object. Now the terminology that we use is like VA with respect to B. Now this means whenever you see this kind of symbol in physics, then remember it's velocity of A with respect to, when I am saying WRT, means with respect to B. So we can have all the kinematical quantities with respect to each other. For example, acceleration, let us say, of A with respect to B. So this is A slash B, that means acceleration of A. You can take notes of this also, of A with respect to B. Or we can say displacement of A with respect to B. This is displacement of A with respect to B. So you can have velocity of A with respect to B, velocity acceleration of A with respect to B, or displacement of A with respect to B. So this is as simple as that, like there is no complication in it. But when you solve the questions of relative motion, then there is some amount of challenge. So there will be two things. So in this particular video, I will be focusing on relative motion in one dimension, relative motion in straight line. That is what I am dealing, and then later on we will be dealing with relative motion in two dimensions also. For example, you are moving and rain is falling from above. Now without wasting much time, let us see what happens when we calculate the velocity of one object with respect to other. For example, I calculate velocity of A with respect to B. Then how do we write it? Like what is the formula for the velocity of A with respect to B? So that is simply VA minus VB. So what I am defining is velocity of A with respect to B. You can note down, it is VA minus VB. Now you should question what is VA and what is VB. इसमें से VA क्या है आपका और VB क्या है. तो देखिए VA का मतलब है, जैसे suppose I am standing here and some car is moving and that car is A, capital A. Now the velocity of that car with respect to a stationary observer, let us say, is VA. Similarly, another car is moving and I am standing on road and watching. Then the velocity of B, as I see, is the actual velocity of B. Now velocity of A in this sense you can say is velocity of A as seen by a stationary observer on Earth. Stationary observer on Earth. So of course all of us are on the Earth only. So if I am a stationary observer and looking at some object which is moving in some direction, then that is what is the meaning of velocity of A. Very important point is velocity, actually speaking, is always relative. There is nothing like absolute velocity in universe. Stephen Hawking said everything is relative. So even when I say velocity of A, it is with respect to a stationary observer on Earth. Similarly, velocity of B is velocity of B, and you complete this sentence as seen by a stationary observer on Earth. So if you are standing, let us say you live in Tiruchirappalli and you are standing on a road and a bus is moving at 60 kilometers per hour, that is simply what we call the velocity of an object, right? And that is what is the meaning of VA and VB. Now the question is, two objects are moving. So now this is one boy, let us say, and this is the second boy. And let us say this boy is moving in this direction. Let us say this is boy A and this is boy B. So velocity of B and velocity of A. The question is, what is the velocity of A with respect to B? So velocity of A with respect to B. The velocity of this boy with respect to B. Or you can also ask velocity of B with respect to A. So don't be confused about this. We can ask what is the velocity of this boy with respect to him and what is the velocity of this boy with respect to him. So the formula says it is VA minus VB, and VB with respect to A is VB minus VA. So the easy tool to remember is in whose respect we take, जिसके respect में हम लेते हैं, जैसे B के respect में लेते हैं, if we are taking with respect to B, then the velocity of B will be subtracted. If we are taking with respect to A, अगर A के respect में लेते हैं तो velocity of A is going to be subtracted. Now suppose velocity of A is 3 meters per second and velocity of B is 2 meters per second. This will be a slightly longer video, so have patience so that I can cover everything. Now velocity of A with respect to B according to this would be nothing but 3 minus 2. So that is 1 meters per second. Similarly, velocity of B with respect to A, that will be VB minus, this is VA minus VB, VB minus VA, that is 2 minus 3 equals to minus 1 meters per second. Now let us interpret this result. Velocity of A with respect to B, with respect to him. So the question is, how does he find moving him? So we find that velocity of A with respect to B is 1. So if he is moving with 2 and he is moving with 3, so he finds that his velocity is 1. And this is logical also, because if you are moving with 2 and you are moving with 3, so actually with respect to him you are moving only with 1, 3 minus 2. But if you ask this boy, so he finds him actually when you say with respect to me, suppose, then that means I am still. And if you ask with respect to him, then he is still. Now if you make him still, actually, so he will find that this is coming with 1 meters per second. Now if you make him still, for example, this is A, and with respect to A this velocity is minus 1. So the physical meaning of this is, if you make him still, then he finds him coming close together like this. Because he is moving slowly, I am moving faster, so I find that he is coming towards me. He finds that I am moving towards him. So these two, you can say, have the same value with opposite signs. If VAB is plus 1, then VBA is minus 1. This will always be a fact. So if my velocity with respect to you is something, say x, then your velocity with respect to me is minus x. And because velocity is a vector quantity, so plus and minus has a meaning. Now in this case, let us say this was case 1. Now in case 2, suppose I say VA is equal to 3 meters per second and VB is equal to 4 meters per second. So that means he is moving faster. So common sense, if you apply, he is moving faster, so he will find that he is moving away from him. And since A is moving slower, so if you make him still with respect to him, let us say, because he is moving faster, so he will find that this boy is going away. Sometimes imagination is a bit difficult, like for those of you who have a little weak imagination, you can simply follow this rule. VA with respect to B is VA minus VB. So for example, here if somebody asks you velocity of A with respect to B, so your simple answer should be 3 minus 4, it is minus 1 meters per second. So B finds him going away, because this sign is minus, minus means this, plus means this. So it basically means that he finds him going away, which is logical because he is moving faster. So if I am moving faster and something is there, so I find him the gap increasing, the gap is increasing. So this is what we are talking of, relative velocity. So now you know velocity is displacement upon time. Velocity is displacement upon time. So if somebody asks you to define relative velocity, then how would you define it? Suppose in an examination you are asked what is the physical meaning of relative velocity. So if this is not visible, let me write here. Relative velocity in terms of displacement. So relative velocity is relative displacement upon time. See, velocity is displacement upon time. I am only adding the word relative. So you can say relative velocity is the rate at which the relative displacement is changing. So एक simple सा formula आप एक तो ये याद कर लीजिए. This is for velocity. For acceleration, I told you acceleration of A with respect to B, just the symbol will be changed, is acceleration of A minus acceleration of B. Once again, velocity A means like velocity as seen by a stationary observer on Earth. Velocity of B is as seen by a stationary observer on Earth. Okay. Now we will look at some practical problem. Very simple problem. Because see, in physics, most of the students, they tell me like we find challenge in solving questions. So in the first place, have a little patience for these videos so you can understand everything. Now suppose this is one boy or one girl, whatever. I am not like biased for boys and girls. It can be anyone. But like it can be a boy, it can be a girl. Now suppose the separation between these two is 100 meters. Now suppose his velocity, he is A, once again he is B. So velocity of A is 4 meters per second and velocity of B is in this direction, which is 6 meters per second. So B is moving pretty fast. 6 meters, like fast means not very fast, but almost running. 6 meters per second is almost running. He is also running slower. Now the question is, when and where do they meet? When and where do they meet? So ये आपका एक problem create हो गया. This is a question which has been created for you. तो देखिए, now this is clearly a question of, now when I am saying A, so this velocity of A means if I am also standing here and watching, so I am a stationary observer on Earth, so I find he is moving with 4 and this is moving with 6. So with proper signs you can say velocity of A is 4 meters per second, but since velocity of B is in this direction, we should also give a sign to this, otherwise there will be a problem. So we should say that velocity of B is minus 6 meters per second. Now the question is, how does he find him moving or she finds him moving, whatsoever. So we will say that velocity of A with respect to B. When I am saying with respect to B means how does he find her moving? If she is a girl, let us say. So how does he find her or he find him moving? So the formula says it's velocity of A with respect to him, So this is velocity of A, which is 4 minus velocity of B, which is minus 6. Now if you forget this minus 6, it would be a trouble. So that creates a trouble for the students. यहीं पे थोड़ा सा mistakes हो जाते हैं. So we should remember, I am writing it properly, I think it was missed. So velocity of B is minus 6 meters per second. So all of you understand this point? That velocity of A is 4, velocity of B is minus 6. Why? because this is my positive direction and this is my negative direction. So he is moving in positive, he is moving in negative. So velocity of A with respect to B is VA minus VB. So minus of minus 6. See, these are the small points where we make mistakes. So that is 10 meters per second. Now this is common sense also. They are moving towards each other. So when you move towards each other, then the relative speed is increased. When you are going away from each other, or let us say if you are moving in the same direction, relative velocity is decreased. If two things are moving together, so relative velocity is very high. Two buses, they are approaching, relative velocity is very high. So velocity of A, this with respect to him is 10. So if you make him still, then he finds that she is moving with a speed of 10 meters per second towards him. So you will say, sir, how 10? I can not understand. So it's very common sense. See, if this is moving with 6, this is moving with 4, and if you make him still, then what essentially happens is its velocity in this direction, it actually gives to this. So its velocity 6, it gives to this in this direction. So 6 plus 4 is how much? 10. So when you say with respect to you, then you give your velocity to the observer in opposite direction. So for example, if it is moving with 6, so the meaning of relative is if you make him still, then its velocity is 6 in that direction. So with respect to him, and I am saying, that means I am making this person to be at rest, and when it is at rest, then it is moving with 10. Now the question is, this separation between them is 100. So if you look at with respect to him, so he is not still. Actually he is not still, but relative motion means making the observer still. So if it is still, it is moving with 10. So before meeting, this boy or girl should come to this very point, almost to this point, and travel 100 meters. In which direction? Positive direction. So we can write that relative displacement, that is with relative to this B, जिसके respect में हम देख रहे हैं motion, with respect to B, A will travel how much? Relative displacement would be total this thing, that would be 100 meters. And V relative, that is VA with respect to B, I have already written as 10 meters per second. So very simply, if you want to calculate the time, so when do they meet? So you know that time is distance upon speed, but now we are having relative distance, relative speed. So we will say, and there is no acceleration, good for us. Calculation is simple. So that is S relative by V relative. So I have not done anything. See, velocity is displacement upon time. Time is displacement upon velocity. So here time is relative displacement upon relative velocity. So that is 100 upon 10, and that is 10 seconds. So these two are going to meet in 10 seconds. So you can see that this question apparently seemed complicated, but using the concept of relative motion, it has become very simple. But question is, where do they meet? Now second point I want to highlight is, whenever we study motion with respect to this, I make him still. Or if you study motion with respect to him, then you make this person still. So for him, it is moving with 4 plus 6, 10. For him, this is moving with 4 plus 6, 10. So you can say they are approaching each other with a relative velocity of 10. Only the sign changes. Sign changes. With respect to B, A's velocity is plus 10, but with respect to A, if I say velocity of B with respect to A, you know the formula is ulta, reverse of this, that is VB minus VA. So that becomes minus 6 minus 4 minus 10. Just you freeze this video, go back, regress a little, you will find that VA with respect to B, if this is X, then VB with respect to A is minus X. So the velocity of two objects with respect to relative velocities, they have opposite signs. So this is minus 10. So that means for him or her, it is coming with 10. For him, she is coming with 10. But relative velocity is 10 in any case. So time is 10 seconds. But the question is, if you see with respect to him, of course, the relative displacement is 100. But the truth still remains that both of them are moving. It's not that one is still, the other is moving, this is still, this is moving. For relative motion, we assume like this. With respect to him, he is still only this is moving. With respect to him, he is still only this is moving. But actually both of them are moving. So they will meet maybe possibly, for example, somewhere here approximately. Just neglect the body's size. So approximately they will meet somewhere here at this point, let us say. Now how to find it? So to find it, in this time 10 seconds, we actually find the distance moved by one of these. During this time 10 seconds, find the actual distance. So in 10 seconds, for example, how much A has moved? So let us calculate this, because I have already found 10 seconds. So the question when do they meet is clear, 10 seconds. But where? So let us say A moves by a distance how much? In 10 seconds. This is my question. In 10 seconds, how much A actually moves? So that is very simple. So velocity of A, that is actual velocity with respect to a stationary observer on Earth, which is 4 meters per second, and time is 10 seconds. So actual distance moved by A is V into T, that is 4 into 10 equals to 40 meter, and that solves our problem. So this he moves or she moves by 40 meter, and since the total distance was 100 meters, so this moves by 60 meters. Now let us also check. Its velocity is 6 and time is 10 seconds. 6 tens are 60. That is also clear, because 40 plus 60 has to be 100. This total distance is 100. This moves by 40. This moves by 60. So where do they meet? You can say 40 meters to the right of A, or you can say 60 meters to the left of B. So this solves your problem of relative motion in one dimension, a straight line, in a simple situation. So now if you understand this simple situation, then brick by brick, step by step, we can have a little more complex problems, which we will discuss in the problem segment. So this is a theory segment, you can say, with illustration. Then we'll have problem segment, wherein we'll solve a lot of problems for kinematics, Newton's law and all. So this is the beginning of relative motion. Next, another video, I will also introduce acceleration along with velocity and bring in the equations of motion. V is equal to u plus at. So for now, I am stopping this video here. You just rewind it, see it once again what I said, take notes of it. If not clear, then see it the third time. So with this, I am stopping here. See you in the next video.